Hello, students. So I wanted to go over the math equations that I had given you earlier this week and the solutions and the step-by-step how we get to the answers. So let's start off with, you have delivered 3 cartridges of a 2% lidocaine with 1 to 100,000 epinephrine. The cartridge is 1.8 milliliters. Determine the number of milligrams of lidocaine and epinephrine below. So what is important to note here, that there are 2 separate drugs contained within the same cartridge. There is lidocaine and there is epinephrine. So we'll do the lidocaine first. Bring my little cursor. So what do you need to know? So remember how we talked about what the 2% meant and there were a couple of steps? You just need to be able to tell me this equation right here. So 2%, what does that mean? It means 20 milligrams of lidocaine per 1 milliliter of water. And mathematically, it's written like this, 20 milligrams over 1 milliliter. So if you can take the math from this point forward, that's all you need to write on the exam. So 20 milligrams of lidocaine over 1 milliliter of water, we have to times it by 1.8 milliliters because that's the amount noted up here that the cartridge is. So the 20 milligrams is in 1 milliliter and the 36 milligrams is within the 1.8 milliliter cartridge. So 20 milligrams over 1 milliliter of water times 1.8 milliliters, which is how much the cartridge is, which gives us 36 milligrams of lidocaine per cartridge. And I've underlined that because we do need to know the per cartridge amount for later equations. But wait a minute, go back and read the question. I delivered 3 cartridges, so I need to go a further step. And because we've delivered more than 1 cartridge, we times it by 3, or the amount of cartridges more than 1 than we've given. So if we've given 2 cartridges, I'd multiply by 2, but in this particular instance, I've given 3, so I multiply by 3. So it's 36 milligrams of lidocaine per cartridge times 3 cartridges, and that gives you 108 milligrams of lidocaine in 3 cartridges. So that's the answer for the number of milligrams of lidocaine that you've given. Now we'll figure out the epinephrine. So the 1 to 100,000 means 0.01 milligrams of epinephrine per 1 milliliter of water. And this is what the mathematical equation looks like. And we already know, because we've discussed in the first equation with lidocaine, that we're not really interested in the 1 milliliter because the cartridge here is 1.8 milliliters. So the math equation that you'll need to start is right here. 0.01 milligrams of epinephrine over 1 milliliter of water multiplied by 1.8, because that is how much we have per cartridge, equals 0.01 milligrams of epinephrine per cartridge. Now again, I've underlined and bolded this because we need to know the amount per cartridge in a later equation. But don't stop there because that's per cartridge. Go back up, read the question, up 3 cartridges. So then you need to take the amount per cartridge, multiply it by 3 cartridges, and you'll get 0.054 milligrams of epinephrine in 3 cartridges. Now, what if, for example, we delivered half a cartridge? So when you deliver less than 1 cartridge, you'll need to divide in this equation right here. If you deliver more than 1 cartridge, that's when you need to multiply, as we've demonstrated here. All right, let me scroll down. All right. So using the information from question 1, determine the maximum number of cartridges that can be administered based on the lidocaine and based on the epinephrine. Determine which drug is the limiting factor and why. So the patient is healthy and weighs 150 pounds. The MRD of lidocaine is 2 milligrams per pound, and the absolute MRD, maximum recommended dose, is 300 milligrams. The MRD of epinephrine is 0.2 milligrams. So let's figure out whether we're going to use the absolute MRD or the weight-based MRD. So the absolute MRD right here is 300 milligrams of lidocaine. The weight-based is 2 milligrams per pound. This particular patient weighs 150 pounds. So if we do the 2 milligrams per pound times the 150-pound patient, we'll also get 300 milligrams. So in this particular case, the absolute MRD and the weight-based MRD is the same. So we'll use the 300 milligrams. And we'll do the lidocaine first. So the MRD we'll be using is 300 milligrams over the 36 milligrams of lidocaine per cartridge. And remember, whoops, wait a minute, scroll up. We solve that up here, that we have 36 milligrams per cartridge in question 1. So that's where I got the 36. So we got the 300 milligrams here over the 36 milligrams of lidocaine per cartridge. The lidocaines cross off, and based on lidocaine, you can deliver 8.3 cartridges to this patient. But wait, there's more, because that cartridge also contains epinephrine. And here, the MRD for this healthy patient is 0.2 milligrams of epinephrine. The per cartridge amount of epinephrine, we've solved that up here, is 0.018 milligrams of epinephrine per cartridge. And that gives us 11 cartridges can be delivered to this patient. So which drug here is the limiting factor? Well, it would be the lidocaine, because we have to always defer to the drug whose maximum recommended dosage is reached first. And in this instance, it's lidocaine. We will reach the maximum dose of lidocaine first, so that drug is the limiting factor. So this patient, this healthy 150-pound patient, based on both drugs, can receive 8 cartridges. Look at this, we're moving right along here. Oh, this is a little tricky. So you have delivered 1 cartridge. Oh, well, that's a not tricky part. Oh, 1 cartridge, that's hooray, right? So we don't have to do that extra step. Of 4% articaine with 1 to 100,000 epinephrine, and the cartridge is 1.7 milliliters. Determine the number of milligrams of articaine and epinephrine below. So let's do the articaine first. So what's 4% mean? That's 40 milligrams. Oh, this should say articaine. Wait a minute. Of articaine per 1 milliliter of water. The mathematical equation looks like this: 40 milligrams over 1 milliliter of water. So you need to be able to get the equation here. The 4% is 40 milligrams over 1 milliliter times 1.7. Where did I get that 1.7? Right up here in the equation, 1.7. So you times or multiply the 40 milligrams multiplied by 1.7 milliliters. I'm going to run out of time. I have to stop this, so I'm going to start it up again in a minute. I'll do a second one.